I'm John Wilker, the organizer of 360 IDEP. I hope you enjoy this session recording, but first I wanted to mention one thing. We've served the community since 2009, and over the past few years we've had to take on debt in an effort to keep the conference alive. After several unforeseen challenges, not the least of which is a pandemic of indefinite duration, we've had to make the hard choice to end the conference as we're now facing over $100,000 in debt. As a result of requests from the community of how they can help, we've created a GoFundMe campaign. If you're inclined and able, please consider donating to help keep 360 IDEP going. The QR code after this will link you to the campaign. Thank you. Enjoy the recording.
Hi, everybody. My name is Michael Matranga. I'm a senior mobile engineer at Bitrise, and today I'm going to talk about building Bitrise automations with Swift. So before we get started, just a little bit about me. I've been working on mobile since about 2010, and my first language I've used to write a production application was Objective-C. I've been with Bitrise now since about March of 2022. And previously, I was working on the platform team at Compass, where I actually managed their whole continuous integration and release process. A couple things in the software world I'm very passionate about is working with hardware, working with audio, and also, of course, continuous integration and deployment. So we're going to start today with a little problem statement, right? If anyone's kind of worked with automation and mobile, we kind of know that oftentimes we need to context switch quite a bit, right? A lot of the automation code we're going to be writing is often in Bash or Go, some other language that we're not super familiar with. So context switching can be pretty expensive. And a couple key things that I think I've encountered, I'm pretty sure some of you all have done so as well, which is like Bash is pretty hard to maintain. Writing Go, I actually really like writing Golang. I think it's a really nice language, but it can be very unfamiliar, specifically when it comes to setting up debugging tools and things like that. You have to really make sure your system's configured just so, otherwise you're going to have some problems there. And additionally, debugging Bash can be tricky outside of your production environments. So some of the things we're going to go over today to resolve some of those problems is really quickly, I'm going to give an overview of Bitrise for those of you who are unfamiliar. And I'm going to talk about how we can write some Swift code already currently in Bitrise. And then we're going to see if there's maybe a way that we can do that a little bit better. And then we're going to talk in terms of custom integrations, development workflow for specifically tools written in Swift, and also some testing, debugging, and deployment workflows for our automation code. So really quick overview of Bitrise. Bitrise maximizes app impact by automating, accelerating, and improving mobile engineering processes, enabling mobile product organizations to develop high-quality apps efficiently and confidently. The team, we were started with a very small team in Budapest, Hungary. All mobile developers kind of solving their own problems, deploying and testing and continually releasing apps. Now we're over 200 people across multiple continents all across the world. And we work closely with and learn from some of the world's leading mobile product organizations. So to sum it all up, one sentence, Bitrise helps you build and operate better mobile apps faster. So how does it all work? What we're looking at right now is sort of the workflow editor in Bitrise web app itself. You can see here, we basically allow you to select different integrations that you'd like to do. And this one's very simply showing that you have a Git clone step, a cache step, some Xcode steps, etc. And so through Bitrise, developers automate their processes required for integration, testing, and deployment of their mobile apps. And additionally, on Bitrise, there's no hardware to maintain, right? We have a basically virtual cloud where we host Mac and Linux boxes. And we keep them up to date with the latest tools, latest Xcodes, including beta versions. And that's sort of how we manage the consistent and clean environments for your builds, right? Every time you fire off a build, we kind of turn on a brand new VM for you with a clean environment. So there's no pollution in the namespace, and you also get clean and consistent results every time. So let's talk about some of the integrations we already have, right? There's a lot of stuff you can do with Swift and Bitrise already. There's build steps, test steps, utility steps, and really any tool that you're using in your build or deploy phases can be wrapped in Bitrise if it hasn't already. And we can see just a few of the examples here. You have Swift Package Manager, Swift Lint, Swift Format. All these things already exist as integrations in Bitrise. So say you want to write your own custom integration in Bitrise. What tools can you use to do that? Currently, the supported ones are Bash and Golang, right? Now, these are very familiar tools for things like scripting. We've all looked on Stack Overflow for like, how do I do X? And it's like a Bash script from 7 years ago that seems to work mostly, right? These tools are great because they're portable across many systems and architectures, and they're also very familiar, like I just mentioned. And so the other cool thing is with Bash, you can sort of wrap any other tool that you need to use by calling it directly from the Bash shell. So can we do automations with Swift now? And the answer is yes. So there is sort of this archaic way that you can do it, and I'll show you a couple examples, right? So this is one way, and we can see here it's very contrived, but what it's doing is setting up a Bash environment, echoing some code into a Swift file, giving it execution rights, and then executing it, right? This is a bunch of glue code to effectively execute a Swift file. Another way you can do it is in a standard Bitrise script step. You can sort of just write this code in here and dump it into the step itself, and the system will execute it with the shebang at the top there. And so this is something you could do, but there are some trade-offs, and I will go over that in a little bit. And of course, the final way is to have a wrapper script, right? You can see what's happening here is we're using Bash to effectively tell the Swift compiler to execute this step. Again, there's, pretend there's some step file with Swift code that is executed by the system itself. So there's going to be some limitations to these approaches, right? A lot of these are going to be around sort of package managers, right? So I can't use third-party dependencies for something like this, right? These are scripts that are run inline, kind of in a very traditional scripting fashion. Additionally, the code's going to have to be compiled every time. So there's no way to point to an executable, and you're still going to need to write some Bash to glue it all together, right? So that's another thing that can be painful for some people. And then finally, when we're writing these automations, unit tests are our friend, right? Unit testing this code actually is going to help you keep it very, very strong and up to date. And of course, unit tests are the best for that. So is there a better way to do this, writing Swift code to produce our automations? And the answer is yes, right? So as of the latest version of our CLI, version 150, we now support steps written with Swift with tools like Swift Package Manager. So there's some really nice benefits to this approach. And so I'll just name a few of them here. So you can compile on demand for quick development. So when you're developing your automations locally, you can iterate quickly by sort of running them over and over again and testing them as you write them. But once you're done and you're happy with your automation, you can pre-compile that binary and host it somewhere so it can be executed very quickly. And I'll demonstrate that later. Third, we can use SPM, right? We can use all of our favorite tools, all of our favorite libraries, and integrate them into our package in any way we see fit. And additionally, when you're writing these automations, you can just use all of your familiar favorite tools for unit testing. So XCTest and anything else in that realm is totally usable now. And of course, now we don't have to write any Bash, which I think is awesome. So I'll leave this slide up for just a few minutes. I'm going to demo some of the features of a custom automation that I wrote in Swift, and it's using Swift Package Manager. And basically, it's a simple wrapper around git clone. So pretty much every automation flow in Bitrise is going to have to clone a repository to get its job done. So that QR code will take you to my repo. Now I'm going to show off a bunch of code here in the next few slides. So first thing we need to cover is sort of the anatomy of a step, right? A Bitrise step is going to have a few things that it needs to do, right? So we're going to have to declare our input parameters. We're going to have to describe our use case for all of our users since it's going to be open source. We're also going to have to validate our input, and we're going to have to export any output parameters. So one thing to keep in mind when we're developing our steps too is that we want to make sure that we're logging a lot of stuff to the console, right? In the Bitrise app, you're going to see as your code runs, it's going to emit all types of information for you. Logging is going to be, especially as your automations get more complicated, logging is going to be the best way for you to track down issues when you're in production. So in a minimal Bitrise step, we're going to have a few components, right? The step YAML is going to be the step metadata for our integration with the system. So this is where we define our outputs. This is where we define for users, what inputs we need, which ones are required, what their use cases are for, etc. We're also going to have a Bitrise YAML in this project, and this is going to be generated for you by the system, but this is basically another way that we describe metadata for the system so it can understand what this step does. And then finally, we're going to have a sources directory, and that's where we're going to keep all of our code that we ultimately execute in the step workflow. So we can see here a small snippet of a step.yaml. And we can see here we're defining a thing called a toolkit. Now, previously, you only had bash and go, and we've added Swift. We can see the two parameters here, binary location and executable name. So what these are going to tell the CLI and the Bitrise system is where to look for your precompiled binary if you have one. And you can see in this case, I've put it on GitHub, but that's not necessarily required. You can put it anywhere you'd like. If you're using Artifactory or something like S3, you could place it in any of those places as well. And the executable name simply tells the automation, or it tells the CLI what to call your executable when it needs to run it. So let's look further down in our step YAML, and we can see the input configuration. Now, since we're doing a git clone, we're going to need some information from our clients to make sure that we can do this job correctly. So we can see we have two required inputs, repository URL and clone destination, right? If we think about what a git clone needs, we're going to have to tell it where to get the repository and where to put it when it's cloned. We also have a couple optional parameters here. Checkout branch is going to say, hey, if you want to check out your main branch or some other branch, you can specify that. And the clone depth, which is going to be a nice little performance optimization for large repositories with a bunch of commits. We can specify one single commit or maybe a dozen, whatever works best for us. So now that we have all the inputs defined, we can start digging into our package itself. Now this is the big optimization I think that we're adding here with this support. So now if I'm doing git clone in my package description, I can bring in third-party dependencies. So you can see here I'm using gitkit, which is a nice open source wrapper around Git that is written in Swift. And I'm also going to bring in TSC Basic, so I can do things like command line argument parsing and has some nice extensions for file system access. So how do we use that input once we get it, right? This is some Swift code that I wrote in my package, and it's a struct that defines the config. I'm sorry if that's a little small there, but basically what this is going to do is define a struct that is defined in Swift that can tell us the sort of config that we need. And we can see here it mirrors my sort of YAML definition where repository URL and clone destination are required. We can see in our initializer, if they're not passed, it's going to throw an error, right? This is going to be a very nice way for us to fail very loudly and very quickly if somebody uses our step incorrectly. And then additionally, you can see the optional parameters below, checkout branch and clone depth. Those are optional, and if you don't pass them, we don't care. So the next thing we're going to do is define our entry point. And in the repository, if you're following along, this is the file called main.swift. And we see it's very simple. It doesn't do a whole lot of stuff, right? All it tries to do is extract and execute, or an exit code from this Swift clone step runner. It prints a positive message for us, and then it exits with the exit code that we received. If the runner encounters an error, we catch that error, we print its description, and we exit with a failure. So what does the Swift clone step runner do? You can see it's just a simple enum that exposes a static function called run. And you can see each one of these steps is sort of doing a very specific job. So first we try to make a config, which is going to pull the envars off the file system and make that config. If that thing fails, it's going to fail right up to our entry point and emit an error immediately. The next thing we're going to do is try to clone the step with that config, or I'm sorry, we're going to instantiate a Swift clone step with the config. And then we're going to try to create the clone path. So that's going to go and dig into the file system and try to clone for us. And then lastly, we're going to run the actual clone. And you can see we've broken this into 4 very discrete steps. And this is intentional so that later that we can show off some of the unit tests for each one of these things. So this is kind of the meat of it. This is the Swift step struct itself. So you can see here, it's a very simple struct. It has one property, which is the config that it has to be instantiated with. And then we have a nice computed variable here, which is the git clone args. And this is where we use the config to sort of generate the arguments that we're going to pass to our git wrapper. And then below that, we have this git clone path where we use TSC Basic to dig around the file system and try to create a path for the directory. And finally, clone repos where we actually interact with gitkit and do the clone. So now that we have all that sort of defined, right, how do we test this stuff? Well, the beauty of writing a Swift package is that you just write normal unit tests like you would for any other package or app or anything like that. You can see I have a couple examples here, and I'll show these off in a little bit more detail later. But the idea is, on the left here, we have the build git command tests. And this sort of tests the functionality of, given a config with a very specific setup, what are the commands that are emitted by that property, right? And there's a bunch of tests that validate that. And then additionally, we can see some config parse tests where it's very much the same, where we can say, hey, does my config fail if I forget to pass a required argument? Does it behave correctly when I provide all of the arguments, etc.? And we can see this is on the very far right, this is my steps, unit test output in Xcode. So we'll talk a little bit now about some of the workflow. So what I've done is, at the very top here, you can see this is the Bitrise YAML for the app I'm developing against, right? So the app is called Bitrise iOS Sample. This is the application I'm shipping and testing at the App Store, right? And what we're going to do is we're going to tell Bitrise to look on my local file system and use Bitrise step clone. So we can see here this path, and then this is a absolute path to my step on my file system. This is how we're able to test and debug locally for all of our automations. We can see here the step YAML for my actual step itself. The Swift toolkit, we can see that we omitted the other parameters, binary location and executable name. This is because we're executing it locally, and the CLI just knows how to pick all this stuff up. And again, I'll show a little bit more about that in a minute. And so after you're done developing your step, you're confident it works, you like it, you use the standard Swift tools to release it. So all we do is we tell Swift to build for release, we go into our build directory, and we host it somewhere. And you can see here, this is just a link to my GitHub where the release actually lives. But again, this could be anywhere that you host any artifacts at your organization. So let's dig into some code and see what this all does. So I have here first my Bitrise clone step, and we can see a couple of the interesting things, right? This is my step YAML, and this is the definition that we kind of went over. These are the envars that we defined, right? And yes, I'm sorry. Oh, the font. Oh, yes. Thank you. That's probably better, right? Sweet. So we can see the toolkit here, and we've omitted, again, the executable name, etc. So this way it understands to pick it up locally. And these are the envars that we tell our config to use, right? And we can see here, we use those with the coding keys. And that's how that all kind of falls together. And additionally, we can run our unit tests, and they run very quickly, which is awesome. And we can even use tools like coverage to understand how we've covered all of our test cases, right? So we can see this file is actually really well covered. One thing I kind of wanted to show off was, down here, this is one gap that we have, right? And I didn't do this, but one thing you could do is have a protocol here where, it's like basically wraps your Git implementation. If you really wanted full coverage, if this is doing something very complex, that's probably something you'd want to do. In this case, I decided to omit that for brevity, but it is possible to do. And so when we're using this, we will flip over to our actual application. I think this comes up in Xcode. No, it doesn't. Let's pull this up here. So this is our Bitrise iOS sample. And we can see in our Bitrise YAML here, this is where we define sort of the workflow steps we'd like to do. So I've set up two. One is called primary, and another is called local. And let me make this bigger for everybody. So one is called primary and one is called local. And basically the difference here is the primary one uses our live implementation, which is on GitHub. And this is where it's going to be able to use the precompiled executable, so it gets a really, really fast runtime. And then down here, the local is going to point to the one on our file system, which has the sort of setup so we can compile and run locally. So let's see what this looks like to actually use. So here in our terminal, we're going to use the Bitrise command line tool to actually run this and test it. So the first thing we'll do here is, and I'm removing my temp directory where we clone stuff, but basically I'm telling Bitrise, look at that YAML and run the local workflow. We'll see what's going to happen here. It's going to go in and I'll show this off really quick. So it's going to pull my step in. It's going to recognize that the toolkit is Swift, right? And it's on the local file system. And then you can see here, it's actually using SPM to compile and download all those third-party dependencies and then clone. We can see that took 15 seconds, right? In production, that's probably way too long. But for a dev workflow, this is what you're going to be able to do, right? And then it's going to go down here and it's going to start running all of our tests, etc. So I'm just going to stop this process here. But that's the basic sort of workflow for dev. And then if we wanted to do the primary one, we can run that here and we'll see much faster speed up. So again, it's going to see that it's going to go to GitHub for my step here. It knows that it's going to be in Git, and it knows the toolkit is Swift, and it executes that code in under 3 seconds. Right, so we have a nice, fast Git clone step here, and we can see it's going to go ahead and run all our tests for us down here. So that's the workflow for the Swift steps with Swift Package Manager. So I hope we all learned a little bit today. So some things that we can now do, which is create a Bitrise step using Swift. We can use precompiled binaries to make our workflows very fast. And we can also develop them and debug them locally with very familiar tools. And so again, that's another QR code for the repo if you didn't get it already. So I would just like to say thank you. And I'll open up for any questions if anybody has any. Yes, so the question is, can you install the Bitrise command line tool with Homebrew? And the answer is yes. You just do brew install Bitrise, and it comes right down. And actually, that's kind of funny that you asked, because I have a hidden thing here where I actually force the Bitrise version. But yeah, you tell Bitrise, once it's installed, you actually just tell Bitrise to update, and it can do that itself. But yeah, initially you start with brew. Great, anybody else? Alrighty.